All right, so now we're going to work on understanding absolute value inequalities. So our first absolute value inequality is the absolute value of x is less than 3. So here's how we want to think about this. The absolute value of x is the distance to 0, right? So we're saying the distance to 0 is less than 3. Here's what that would look like on a number line. Here's 0. I know that I can go 3 away to the right, and I can go 3 to the left. So let's say I'm 3 to the right. The distance is less than 0, so the distance is less than 3, so I can't include the 3. I'm going to have a closed circle. And then what distances are less than 3? Right now, this distance is 3. So I can't have distances bigger than 3 out on that side, right? So to have smaller distances, you actually are coming in. All of these distances to 0 are less than 3. So maybe it's a distance of 1, a distance of 2, a distance of 2.9. Those are the distances less than 3 on that side. Well, you also could be on the other side of your number line because the distance from 0 to negative 3 is also 3. But we want that distance to be less than, because it is a less than right there, 3. So we're not including that value, so we're going to have an open circle. But how do I make that distance smaller so it's less than 3? It's going to be all the distances here. So from 0 to the left 1 is a distance of 1, distance 2, distance 2.9. And what we recognize is this is turning into an and compound inequality. So how do we write the inequality for this? We actually can start from this up here. If you take the bars off, we can say that x is less than 3. That's right here. X is less than 3 are those right there. And x is greater than negative 3. So we're saying greater than the negative 3 over here. Ultimately, what we did was we took the bars off, x is less than 3. We know it's an and because we want those distances to get smaller. Those are going to go towards 0 to get smaller distances. So we made it an and then we flipped our inequality to make it greater than, made the number negative 3. That's taking care of those distances on that side. Solve and graph, well, we solved it because x is alone. X is less than 3 and x is greater than negative 3. And we graphed it. We kind of graphed it first as we were explaining what this would look like. So an absolute value inequality turns into, when we solve it, a compound inequality, either with and or. So let's take a look at example B. So the absolute value of x is greater than 3. So remember, absolute value of x is the distance to 0 and then because it's a greater than, we're going to say is greater than 3. So what does that mean? Well, let's just kind of look at a number line again. If our distance is 3, I know I can go 3 to the right and 3 to the left. But we want the distance to be greater than 3. So from 0 to 3, that's a distance of 3. But I want distances bigger, so it could be a distance of 4, 5, 6, and so on and so on. So what that's going to look like is I'm going to put an open circle on 3 because we're not including it, and all of these distances that way. So from 0 to 3.5 is hitting right there. 0 to 10 or whatever is hitting right there. So distances greater than 3 is going to start heading out, so we get bigger distances. So here's another big distance. From 0, here's another big distance. All right, but we do have a distance of 3 the opposite direction, so we're not including the the -3, we're going to put an open circle. By the way, these will always have the same open or closed circles with these absolute value inequalities. And then how do we get a distance greater than 3 over on this side? Well, from here to here is a distance of 3. So distance of greater 3, I've got to get to a distance of 3.1, a distance of 4, a distance of 5, a distance of 10. So those distances are going to go that way, and what we notice is that this is turning into an OR compound inequality. So how we're going to write this is we're going to take we can go straight from here if we understand if your distance has to get greater than 3, that turns into an OR. You take your bars off, x is greater than 3, that's this side, or x is less than -3. That's this side over here. So again, we flip the inequality and we change the sign. This up here, absolute value of x is greater than 3, is the same thing as that. We just rewrote it as a compound inequality and we can solve for x. Now x is already alone, so there's no solving to do, so we're set. But that's why we're able to write that as a compound inequality.